Alright, solving with variables on both sides, day 2. Gina has paid 4 paychecks and $5. George had 3 paychecks and $17. They have the same amount of money. Write an expression for each paycheck. Well, if we let P equal the paycheck, then Gina has 4 paychecks and $5. George has 3 paychecks and $17. So what do you know about the amount of money that Gina and George will have? They told us that they have the same amount of money, meaning that these two expressions must be equal. So 4P plus 5 has to equal 3P plus 17. How much is each paycheck, and describe the process you used to solve the equation? Well, let me rewrite the equation. 4P plus 5 equals 3P plus 17. As I work it, I'm going to describe how I solve it. So, since there are P's on both sides of the equation, step number 1, get the variables together. So, I'm going to subtract 3P on both sides of my equation. On this side, that leaves me with P plus 5 equals 17. After that, you're going to use inverse operations to finish solving. So, we're going to subtract 5 on both sides, and so P is going to equal 12. So, P is 12, that means each paycheck is $12. Alright, now we have a couple more equations to practice solving with. When I look at number 2, I should see parentheses, and we should first distribute. Anytime we see parentheses, we should probably take care of distributing first. So I have 9V plus 12 equals 3 times 3V, that's 9V, and 3 times 4, that is 12. Okay, again, if you had to collect like terms, you would collect like terms, but we don't have any in this instance. Step number 3 is to get the variables together. So I would subtract 9V on both sides of the equation. That'll leave me with 12 equals 12. Hey, wait a minute. That's a little strange. 12 equals 12? Well, if you think about it, isn't that true like all the time? Something that comes out and is true all the time means that these two equations were equal to each other to begin with. So, like, look at these two equations. 9V plus 12, 9V plus 12. Of course they're equal to each other. So what we need to do then is say that it is all real solutions. Every number that we plug in for V will make this equation true. Alright, on number 3. There is no distributing to be done. I cannot collect like terms, so now I'm going to get my x's together. So I might add x to both sides of my equation, and then I have 6 equals, this is going to be 6x plus 2. I then subtract 2 on both sides. I've got 4 equals 6x. And finally, divide by 6 on both sides. So x is going to be 2/3, and for all of you decimal lovers, that is 0.6 repeating. Alright, last equation here. No distributing. I do not need to collect like terms. Let's get the k's together. So I'm going to subtract 2k on both sides of this equation. So that way I have 4k minus 3 equals 13. I then will add 3 to both sides. And I've got 4k equals 16. Divide by 4. Therefore, k is going to equal 4. Alright, moving along. Oh, speaking of which, a moving company. Haha. Okay, a moving company charges $800 plus $16.50 per hour. Another moving company charges $720 plus $21.50 per hour. For what number of hours will moving cost be the same for both moving companies? Well, here's the question. We want to know what number of hours. If we can identify the question, then we know what the variables should be. So since they're asking for the number of hours, we say H can be the number of hours. Then we read each sentence one at a time, and we write down what we can. So a moving company charges $800 plus $16.50 per hour. We know plus means obviously plus, and per means multiplication. So if I write that down, I've got 800 plus 1650 times the hours, H. Okay, another moving company charges $720 plus $21.50 per hour. So basically the same thing. 720 plus $21.50 H. Now there's got to be a relationship between those two things. It says, for what number of hours will the moving cost be the same? Meaning they need to be equal. Alright, so to solve the equation, we should probably get our H's together. So I'm going to subtract 1650 H from both sides. So now we have over here 800 equals 720 plus, let's see, that would be 5H. Then we subtract our 720 on both sides. That'll leave me with 80 equals 5H. Divide by 5. So H should equal 16. So it's going to be 16 hours. Okay, next problem. Gina and George were each paid a bonus for every time they worked on Sunday at the amusement park. Gina and George's bonuses were the same amount. Today, Gina received 3 bonus checks and she bought a new t-shirt that cost $8. George received 2 bonus checks and an extra $15 for parking cars last Saturday. They currently have the same amount of money. Find the amount of each bonus check. Alright, so the question is, find the amount of each bonus check. So we could make our variable the bonus check. So let's let B equal the bonus check. Alright, now the first sentence, basically the only thing important there is that their bonuses were the same amount. So you can use the B for both Gina and George. Okay, next sentence. Today Gina received 3 bonus checks. She has 3 B's. But she buys a new t-shirt that costs $8. So she's going to spend $8 of that money. So you have to subtract the 8. George receives 2 bonus checks and he gets an extra $15, meaning plus 15 for those cars. And they have the same amount of money, so they should be equal. Alright, let's solve. So I've got to get my bonus checks together, minus 2B on both sides. So you have B minus 8 equals 15. And finally, add 8 to both sides. And we should get B equal to 23. Each bonus check was $23. Alright, just a couple more to go. Alright, a worker at Burgerland makes $5 per hour plus $5 in tips. Another worker gets $5 per hour plus $8 in tips. How long will it take for the 2 workers' costs to be the same? Alright, so the question is how long? In other words, how many hours? Because our problem is in hours. So H is our hours. Alright, the first worker at Burgerland makes $5 per, meaning multiply, hours, plus, meaning plus, $5 in tips. Another worker gets $5 per hour, so times H, plus $8 in tips. We want their cost to be the same, so they need to be equal. So we get the H's together by subtracting 5H on both sides. you've got 5 equals, oh, whoa, 5 equals 8? That's impossible. Anytime something's impossible, what it means is that there's never going to be a number that I can plug in for those hours that'll make these two workers have the same cost. So this means we have no real solution. Alright, last few examples. We're going to solve some of these equations here. Alright, so again, let's review the steps. I'm not going to write them down this time. If there is parentheses, you should distribute. If you need to collect like terms, you should do that next. Then you should get your variables together on the same side, and ta-da, start solving using your inverse operations. So on equation number 9 here, no distribution, no combining like terms. So I get my x's together. So I think I'd like to add 0.8x on both sides. So that will get me 0.7x plus 0.4. And on this side over here, we just have our 2.5. If I subtract my 0.4 on both sides, I get 0.7x equals 2.1. Then I divide by 0.7, and x is going to be 3. Alright, next equation. Ooh, I see parentheses. So, okay, distribute. 4.2z equals negative 4 times 0.6z is negative 2.4z. Then negative 4 times negative 1.2 is a positive 4.8. Alright, let's get our z's together. Let's add 2.4z to both sides. So over here that's going to be 6.6z and equals to 4.8. We then divide by 6.6. So that z comes out to be not really a nice thing. That's 8 over 11, but if you like decimals, it is 0.72 with the 7-2 repeating over and over and over again. Alright, last but not least, I do see parentheses, but there is no number sitting out here in the front for me to distribute. So this is just a minus 5. Oh, wait, there is a number. It's just not here. So the number in front is 1/5. Okay, so we distribute the 1/5. 1/5 times a is 1/5 a. 1/5 times negative 5 is negative 1. Then this is 3 plus a divided by 5. Alright, we need to get our a's together. But one of them's a 1/5 a and the other one's an a divided by 5. A divided by 5 is the same thing as 1/5 a. It's just 1/5 a. And so then I can get my a's together. Subtract 1/5 a on both sides. And on this side it cancels. You get a negative 1 equals. On this side it cancels as well. And you get 3. Negative 1 equals 3? Well, that's impossible. So that's when we write no real solution.